Hey guys, what's up? I'm going to be showing you how to solve higher order difference equation using the shift operator and auxiliary equations. Trust me, it is very easy. So you just need to know something in addition to what you already know. Now you know how to solve first order difference equations. The ones that we've solved so far, they are non-linear difference equations in the sense that instead of coefficients multiplying these y terms, we have something like this. For instance, x n plus 1 then plus n plus 1 x of n equal to 0. So this one was kind of like in non-linear form, and we had to use some other methods perhaps to resolve it. But this time around, it becomes easy for us to solve it because not only is this difference equation homogeneous, it is also linear. We have linear coefficients multiplying yn terms. Okay, so it makes it easier for us to solve using auxiliary equations and the shift operator. So what is this shift operator? So I just want to give us the hints first before we solve. So the shift operator is defined thus: when you apply a shift operator of order m on a function y of n, it becomes yn plus m. Okay, so in the same way, if you apply minus m yn, it becomes yn minus m. So the shift operator shifts the value of your discrete parameter by some units that corresponds to the power of your shift operator e. Is that okay? So this shift operator is a powerful operator in difference equation, and it will help us to resolve our difference equation. So one other thing I want you to know in addition is that when you're giving y of n plus 2, it's still the same thing as you having y subscript n plus 2. Okay, when you're giving y of n plus 1, it's still the same thing as you having y subscript n plus 1, and so on and so forth. Okay, so I'm going to adapt this convention and this convention a lot, especially this one when we are solving with the shift operator. So I hope we still remember the shift operator. So if I have my g of my y of 2, for instance, and I apply a shift operator, let's say y of 2n, and I apply a shift operator of k, then it will be y of 2n plus k. So the shift operator basically just shifts this guy by k units to the right or to the left, depending on the sign. If it's positive, it's to the left. If it's negative, it's to the right. Okay, so let's see how we're going to use our knowledge of shift operator and auxiliary equations, which I believe we are all familiar with, to solve the problem in A. So solution now. So you're given in the A part, we have 9 yn plus 2, 9yn plus 1, then 2y. 9yn plus 2 then plus 9yn plus 1 plus 2y equal to 0. Now another thing is, when you see y, it's still the same thing as y of n or y subscript n. Okay, so let's take note of that. Now you're given this equation. I'm going to transform it to the form, the subscript form, that is 9yn plus 2 and plus 9yn plus 1 then plus 2y subscript n. Okay, this is the subscript form. And I'm now going to apply the shift operator here. This becomes 9e. Okay, this is 2yn. Okay, just like we said. So you're like kind of tracing your step back. Remember that m of yn is yn plus m. Okay, so if you retrace your step, you get it like this. You now have 9e, okay, raised to the power of 1 of yn, and this one is just what, 2yn. there should have been an e to the 0, but we don't usually put e to the 0. We just leave this one the way it is, equal to 0. So you can now see that you will have e squared plus 9e plus 2, everything on yn equal to 0. Then yn should not be 0, okay, because we want to find the solution. Therefore, we have to what? Consider this, and this is called the auxiliary equation. So you have 9e squared plus 9e plus 2 equal to 0. So in solving this auxiliary equation, we are looking for two numbers. This times this is 18, such that when we add them, they give us 9, but when we multiply them, they give us 18. And definitely, yeah, you got that right. We have a 3e plus 6e and plus 2 equal to 0. So any method of factorization will be good. So I have 3e into 3e plus 1, then plus 2 into 3e plus 1 equal to 0. So 3e plus 2 and 3e plus 1 equal to 0, making my e, okay, in this case I should have changed. When you're solving your auxiliary equation, I know we used e as the e operator, but anybody can literally use any letter you want. You can use m, you can use small letter e, you can just use anything you want, okay, but we are just interested in finding the value of the roots of this other auxiliary equation, and the letter or the variable we use does not really matter, okay, but just know that the e operator is distinct on its own. So we are just trying to still use that letter to find our roots. It doesn't actually mean that e is equal to the roots. No, it's just a letter that we are using to find the root. So this gives me negative 2 over 3, and e is negative 1 over 3. So we've gotten two roots, and these two roots are real, distinct. Now, when you solve an auxiliary equation in difference equation and you get real roots in the form m1, m2, maybe m3, and so on and so forth. Now, for all these real roots, your solution yn is going to be, choose an arbitrary constant c1, then you now have m1 raised to the power of n, and plus c2, m2 raised to the power of n plus dot dot dot. Is that okay? So for the number of real and distinct roots you get, m1, m2, m3, the solution of your difference equation is an arbitrary constant, then the first root to the power of n, arbitrary constants, and another root to the power of n, and so on and so forth. This is just analogous to when we solve maybe m1 and m2 in differential equations, and where we said our y is equal to a exponential m1x plus b exponential m2x. Okay, but this is for differential equation, but for difference equation, it is the root itself that is acting as the base of whatever we are dealing with. Then n is the exponent. So given that we solved this equation and we have two roots, therefore our y of n is going to be what? Negative. Okay, let's choose an arbitrary constant. Let me say I choose c1, then I'll have negative 2 over 3 raised to the power of n plus c2, then negative 2 over 3, negative 1 over 3, sorry, raised to the power of what? N. So this is the solution of the difference equation given to us above. Another thing you might want to be interested in knowing is what is the order of a difference equation. The order of the difference equation is the highest term in n minus the lowest term in m. So this is n plus 0, okay, although it's not written. So if you want to find it, the highest term is n plus 2, and the lowest term is what? Minus n plus 0. So you subtract n plus 0, which is n cancels out, and you have 2. So this is a second order, okay, second order difference equation, and every second order difference equation has two roots, so let's say two arbitrary constants or two solutions, however you want to protect, and this is how we usually form them. So I hope you understood this particular